So let's continue our discussion with dimension analysis. So in this tutorial, we are going to solve more questions under dimension analysis. We want to see how to come up with how to prove that the equation is homogeneous. Okay, so I have got my first question, which is saying prove that the following equation is homogeneous. So what does it mean when you say homogeneous? Meaning the equation has got the same formula, both left hand side and the right hand side. Okay, so now in this case we have been told that n is equal to 1 over 2 pi times the square root of g over l, where n is frequency, g is acceleration due to gravity, and l is length. Now when we are dealing with dimension analysis, we always work with what we call the base units. Okay, so some of the base units which we need to know is time, mass, length. What else? We also have okay, there are a lot, but for now I want us to focus on these three. These are the most important thing. Okay, so when we're talking about time, time is always in seconds, mass is in kgs, length is in meters. Now when we were writing this in dimension analysis, we use what we call the square brackets. So for example, time, if there is seconds, then you put capital T, you put it in that. If it is mass, you put capital M, you put it in that. Then length is capital L, like that. Okay, so let's start. I know that frequency, the SI units for frequency is hertz, but in this case I can't use hertz because hertz is not the base unit, so I need to choose the base units. I know that frequency can also be per second, the SI units, which is the same as s to the power negative 1. So I'll say the left hand side, I have n. Now this n is second to the power negative 1. Okay, second to the power negative 1. Then I'm going to say these seconds can be replaced by t, now to the power negative 1. So now I'm supposed to get the same thing to the right hand side. If I'm going to get the same thing, then this equation is homogeneous. Okay, so the right hand side, okay, the right hand side, we have the square root of g over l. But let's understand the square root. When we talk about the square root of x, it's the same as x to the power negative 2. So meaning this is the same as, let me just get rid of this. This is the same as g over l to the power negative, or to the power half. Okay, meaning that I can again rewrite this to say it is g to the power half to the power 1 over half, then l to the power this. Again, if I want to rewrite this, if I have 1 over x is the same as x to the power negative 1. If I have 1 over x squared, is the same as x to the power negative 2. So now here I'm trying to remove the denominator, or I'm trying to remove this part here, so it can be written as g to the power half times l to the power neg half. Okay, now after doing this, I know that g is acceleration due to gravity. The SI unit is meters per second squared. L is length. Okay, so g will be that. L is length, which is just meters. Okay, next I'm going now to start now plugging in what I have. So I'll continue from here. I'm going to say where there is g is meters, so this can also be written as meters per second to the power negative 2, meaning I've removed per. So it is m s to the power negative 2 times m is going to be m to the power negative. I'm supposed to put these in brackets because it is to the power half. I put half here. Even here is m to the power negative what? Half, which is meters. Now, I'm going to replace now, putting now these, the square brackets. I'll say meters is in length. Okay, it's supposed to be length. So I'll say L like that. Then times half, I'll put it to the power half here. Time is t to the power negative 2. Now negative 2 times half is going to give me what? Negative 1. So I'll put negative 1 here. Again, I have got length, which is L to the power negative half, like that. So if I continue, I can clearly see that this and this, the bases are the same. If the bases are the same, what do? We add the powers. So half minus half is going to give us 0. So any number to the power 0 is 1. Now this and that has disappeared. We have now t raised to the power negative 1. So we can clearly see that the left hand side and the right hand side, we are getting the same thing. Therefore, this equation is homogeneous, hence proved. Okay? So we have the same left hand side and the right hand side. Okay, so that is it for the first question. Then the second question is saying the force F between 2 points, between 2 point charges is given by F q1 times q2 divided by 4 pi r squared times the uppermost node. So this, now they are saying where q1 and q2 are the charges, r is the distance between the charges. So if you have got two charges, once you start doing electric charges, you are going to do this. So the distance between, this is charge, maybe this is q1, this is q2. So the distance between these two is what we call r. So the formula is the force is equal to q1 q2, charge 1 divided by, charge 1 times charge 2, then 4 pi r squared times the uppermost node, absolute node. That's what we, this E is absolute node. Now the next thing we have to do is we want to make uppermost node as a subject of formula, the E as a subject of formula. At this point I can cross multiply here. 1, I'll say I'll have force times 4 pi r squared times this is equal to q1 times q2. Okay, I divide both sides by force, 4 pi r squared, force 4 pi r squared. So this will be given by q1 q2 divided by, I can start with 4 pi r squared times f. Now the question continues to say use the above expression to determine the base units. Now we need to get the base units for each. I'll start with the charge. Charge, the SI units for charge is coulomb. But coulomb is as a result of two things. Okay? So coulomb, in 1 coulomb we have got 1 ampere times seconds. Okay? So meaning these are now the base units. So like I said, the base unit, we have got time, length, we have got the mass, we also have ampere, we also have, okay, we have a lot actually. So 1 coulomb, this coulomb is not a base unit. Okay, it's a derived one. It's as a result of the ampere and the second. Therefore, where there is coulomb, I'm going to be replacing with what? AS. So I'll say this will be equal to, where there is this, I'll say is AS. Now since it is, we have 2, I'll also do that. I will divide this by, the force is in Newton, but force is mass times acceleration. Mass is kg, acceleration is meters per second squared. Now because This can also be expressed as, okay, if I know that these are now base units, so I'm going to replace where there's, now in this case this is a constant, we are not going to consider it, we just ignore it. And R is meters, so I'll start R will be meter squared times, then this will be M, which will be kg, then meters per second squared. So this will be, these two, if we square them, we a times a is going to be a squared, that one will be s squared. Next I have, it's the same as here, I have m times m is going to be m to the power 3 times kg. Now this is p, which is divided by that, so now I'm going to say I divide it by s squared, which is the same as a squared s to the power 2 divided by m to the power 3 kg, okay, then divided by s squared. So now what I'm going to do is what I'm going to do now is I'm going to, I'll say a squared s squared times s squared, okay, then I divide this by m to the power 3 kg. So if I do, if I multiply, I'll have a to the power 2 s times s squared times s squared s to the power 4. Then I have divided by m to the power 3 and kg. Now I can remove this on the denominator, meaning this will be the same as the SI unit for E will be equal to a to the power 2 s to the power 4 then times m to the power, now this is going to be negative 3, then kg to the power negative 1. So these are the SI units for the E which we are looking for. Okay, now the next one is saying student while experimenting finds that the velocity of an object varies with the time, and it can be expressed as an equation v is equal to xt squared plus yt plus z. If the units of v and t are expressed in terms of SI units, and we know that v is meters per second, so meters per second is the same as s to the power negative m times s to the power negative 1. T is also in seconds. Okay, so what I'm going to do now here is when you have been given such kind of equation, you cannot derive the formula using this with everything here. No, you can only do this and that once, that and that at the same time, that and that. So here you start, you say v is equal to x times t squared. You want to find the SI unit for x, divide both sides by t squared, both sides by t squared. So x will be equal to v over t squared. So x will be, my v is meters per second. My t is s squared, because it's t squared, so it's s squared. This can be expressed as m divided by s, then divided by s to the power 2, like that. So it can be s over m over s times 1 over s, like that. Okay, then now we can do times, this is to the power 2. So if that is to the power 2, we can clearly see that we are going to have our x to be equal to meters divided by s to the power 3. S to the power 3, it can be written as, so x will be equal to m s to the power negative 3. So these are the SI units for x in that case. Next, you also get you're going to get v to be equal to y times t. We want to find the SI units of y, divide both sides by t by t. So y will be equal to v over t. Y will be equal to v is meters per second, t is seconds. So now y will be equal to, that is meters divided by seconds, then times the reciprocal of that will be 1 over s. Or if you want, you can first do divided by s, then you do the reciprocal. So we'll have m over s squared. This is the same as m s to the power negative 2. So these are the SI units for y. You can also say y is meters per second squared. That is just okay. Even the one we had, you say x is equal to meters per second to the power 3. That is just okay. We do for the last one. So y will be equal to z. Oh, it's v, sorry. V will be equal to z. V will be equal to z. V is meters per second, meaning that z is meters per second, or you can say meters s to the power negative 1. That's all. So we have question 4, which is saying speed of wave v on a string depends on its mass, length, and the tension force, which is represented by q in this case by an equation v to be equal to m to the power m, l to the power b, q to the power c, where m is the mass. So this will be represented by the square brackets, which is capital M. Okay, so it is in kgs. Let me just write it from here. I'll say mass is in kgs. This has to be replaced by this. Then we also have force. Remember that force, when we're talking about dimensions, we're just using the base units. Force is kg meter squared. Because of Newton, force is mass times acceleration. Mass is kg, acceleration is meters per second squared. Therefore, for force, I'm going to say it is kg times this. So this can be expressed as, it's going to be kg is mass, which is going to be capital M, then meters is length. Then that one is going to be, now since it is on the denominator, it's going to be time, now to the power negative 2, like that. Next we have length. Length is meters, but it has to be like that. Now I can continue. Velocity is meters per second, which is meters is length, per second is time to the power negative 1, like that. So I'll go ahead and now start plugging the values. So v, I'll say it is meters per second. The mass is kg to the power a, then mass length is b to the power that, force is a kg meter per second squared, like that. Then I put c. This can be written as m s to the power negative 1. This can be written as that to the power that mb. Then now I can distribute c. So it will be kg to the power c, meters to the power c. Then this is seconds to the power negative now 2c, like that. Now we'll replace this with the square brackets. So meters is length. So I'll say length. Let me use different color. Time is t, so I'll put like that to the power negative 1. Kg is m, so I'll put m to the power m. m is length, which is going to be to the power b. Kg is mass to the power c. Then again length to the power c. Then again time to the power negative 2c. Now, if the bases are the same, they can be, so I have this and that can be added, that and that can also be added. So I'll have length, then t to the power negative 1 to be equal to that and that can be added like that. So a times I've got t. This is supposed to be c because it's mass. This is c. So it's a plus c is going to be a plus c like that. For length, I have b and c, so it will be b plus c. I'm adding the powers. Then t is alone, so I'll say t to the power negative c. After reaching at this point, what you do is you compare now the powers. We want to find the values of a, b, and c. Okay, you compare the powers. So like here, the left hand side and the right hand side. So the one having m, we don't have anything having m to the left hand side. We don't have anything having l. So therefore, a plus b will be equal to 0. This is the same as we had m to the power negative 0 or to the power 0. Any number to the power 0 is just 1. So that's why we don't have anything. Then for length, we have b plus c. Here we have to the power 1. So it's going to be b plus c is equal to 1. For t, I have negative 2c to be equal to negative 1 here. Negative 1. So I can start finding c. I divide both sides by negative 2. Here, negative 2. So c will be equal to 1 over 2. Okay? After finding c, I can now go to the second part. The second part, I can clearly say that I have b plus c is equal to 1. I have the value of c. b plus half is equal to 1. So b plus, it will be 1 minus half, like that. Okay? So we want to find the value of c. So if we do minus here, what are we going to have? We are trying to find now the value of b. Okay? No, we didn't have, we had the m is a plus c. Here, I'm talking about this part here. The m is a plus c, but me I've put a plus b, so here I'm supposed to put a plus c is equal to 0. Take note of that. Then here for b, this was supposed to be, yes, for b is b plus c, which is just okay because we had l and l, b and c. Yes, so b plus c is equal to b plus c. This b plus c is equal to 1. That is just okay. Okay, so we are trying to find the value of, we have found the value of c, and then we are trying to find the value of b now and a. Okay, so what we are going to do here is after finding, I've just plugged in the values. Let me just start from here again. We said negative 2c will be equal to negative 1. Then now from here, this is to the power 1. So the one having l, we have added b and c. Okay, which is a plus c, b plus c, which is this one. So b plus c for l is going to be equal to 1. Okay, which is this one. A plus c for this m and that m, a plus c should be equal to 0. That is true. Okay, yeah, that is true. And then we want to find now, we want to find b and c. Okay, so the value of c, we have found that if I divide both sides by negative 2, I'll have c will be equal to half. So the c value is half. Okay, the c value is half. Now I'll go to a. I have b plus c, like that. Or let me start with a plus c. It's okay. A plus c is equal to 0. The c value we have, what is our c value? Our c is half. So this will be equal to 0. So I shift this to the other side. A will be equal to negative half, like that. Okay, a will be equal to negative half. After finding negative half, what else? We have remained with what? We have remained with a plus c. Okay, so a plus c is the one we are from finding, but b plus c now. So b plus c is equal to 0. B c is half. Oh, this is equal to 1, sorry, is equal to 1. So we have b will be equal to 1 minus half. 1 minus half is still half. So b is also half. So b is half, and then so we have two halves. B is half. Then we also have c is half. What else? Then 1 is negative half. And let me show you this. The formula for the speed of a wave, like the formula when you start doing waves, is given by the square root of the tension force divided by the linear density. Linear density is mass over L. So in this case, it's the same as we say V will be equal to F divided by M. Then here I'll have, if I do the reciprocal, it will be L over 1. Now the square root. That's the reason why the length is going to have positive half. F will have positive half. Okay, what do I mean? C is half, which is correct. So if I do this, the velocity will be like that. F times L divided by M. So for A has to be negative half, which is true, because you see down here. So these answers are correct. Okay, that's for question 4. Then we have another question which is saying prove that the following equation is homogeneous. Proving, you just get the right hand side. So this is a constant. I will not tamper with it. I will just have m v squared. So I need to write left hand side. Left hand side we have m v squared. M is meters, or m is kg, sorry. Then this is meters per second. But we should remember to say it is meters per second, but it is what? It is squared. Okay, so I'm going to say this has to be squared. So we'll have kg meter to the power 2 per second squared, like that. If I want, I can write this and say kg meter squared. To remove this, I'm going to say s to the power negative 2. If I want to put this in square brackets, kg is m, which is meters, is length, to the power 2, then t to the power negative 2. So if I find the same thing to the right hand side, then it is homogeneous. Right hand side I have m gh squared. M is mass, which is kg. G is acceleration due to gravity, which is meters per second squared. H is in meters, now it is squared. This can be written as kg. M times m squared is going to be m to the power 3, then s to the power s to the power negative 2, like that. Okay, so next I'm going to say kg is in like that. Then this is going to be meters, which is length, to the power 3. This is in time, which is to the power negative 2. We are done. So the left and the right, they are different. So this is not homogeneous. This is to the power 2, this is to the power 3. The rest are just the same. If this formula was like this, just like that, it would have been homogeneous, because here would have just remained with m. So m times that one would have find l to the power 2. So since they squared here, this is not homogeneous. Okay, so that's how you prove. So the last question is using dimension analysis, show that the velocity v of a body falling freely under the gravity varies with the square root of g over h, where g is the acceleration due to gravity and h is the distance through which the body falls. So we have been told that we should show using dimension analysis that v can be given by the square root of gh, like that. How do you show? This is what we are going to do. So you say v is direct proportion to h and g and h. Initially we replace this to be equal to k with this. K is constant, so I'll say v will be equal to, okay, so from the formula here I can clearly see that k will be 1 because k is constant, so I'll not tamper with it. Even if I leave k, I'll just say it's given by gh. Okay, so I'm going to assign letters to be the powers. I'll say this is a, this is b. Now I need to find the value of a and b, and we see if we're going to have this. So what I'm going to do now is velocity is meters per second. Acceleration due to gravity is meters per second squared, now to the power a. Height is in meters to the power a, to the power b, sorry. Next, this can be written as m s to the power negative 1. This can be written as m to the power s to the power negative 2, like that. Then m to the power b, like that. I can go ahead and say, and now start replacing. M is meters, is going to be replaced by length. Time will be replaced by t, now to the power negative 1, is equal to, here now, this is the same as m to the power a, s to the power negative 2a. So I'll say meters length to the power a, then time to the power negative 2 times a is negative 2a. Then I've got again length to the power b. So if the bases are the same, we add the powers. So I'll have that. So now I'm going to say a plus b is going to be length a plus b, like that. Then t negative 2a. So we compare now the powers. Here is same as to the power 1. So this will be equated to equal to 1. So I'll say a plus b is equal to 1. Then negative 2a will be equated equal to 1. So I'll divide both sides by neg 2, both sides by neg 2. A will be equal to half. Done. If a is half, so I'll say half plus b is equal to 1. Shift half to the other side, b will be equal to 1 minus half. So b will be half as well. B value will also be half. So let's go ahead and now, after finding these values, you go back and plug in the values. You see if we're going to have the same. So we are saying it was v is equal to g times h. So this was a, this was b. So V will be equal to G, A is half, H is also half. Since they are all half, I can say G times H, everything in the brackets, to the power half. To the power half is the same as the square root of GH. So now I've shown that this formula is coming from here, like the way I've derived it. That's the formula which I've been given, just to show that it is the square root of G times H. So that is it for this video.